Hi guys, now for these problems, also involved with logarithmics, but in this case it's natural log. We're going to work with the same approach, but solving for natural log and using the inverse of natural log, which is e. Alright, so let's go here and write something interesting. You know, the inverse function of natural log is e to the x, because natural log of e to the x is equal to x. Yeah, check the formula sheets and all the rules in the chapter. Then also e to the natural log of x is equal to x. That means that e and natural logs are inverse function. And if you look at the graph, if we were drawing the graph of these two, one looks like this, the other one looks like this, and they are symmetrical with respect to the origin. This would be e to the x, and this is the graph of natural log of x. Yeah, sort of. Remember, this would be y, and this is x. Yep. Okay. So, and in general, you can do this. Natural log of e to the f of x is going to be the function f of x. And the same way, view e to the natural log of f of x is going to be f of x. Now, going to the problem. The problem says, we're going to rewrite it here. 3 natural log of 4x is equal to 21, right? The first thing we're going to do, we have to solve here for x. The first thing we're going to do, we're going to divide everything by 3. We're going to get rid of this 3. So then we have what? Natural log of 4x is equal to 7, right? Because 21 divided by 3 is 7. And now that we have this, we're going to apply here e. So we apply e both sides. Applying e both sides, we will have e to the natural log of 4x is equal to e to the 7. E natural log of 4x is actually, by definition, by using the rule of this one, f of x is going to be f of x. In this case, f of x is 4x. 4x is equal to e to the 7. Now, solving for x, we divide both sides by 4. And x is equal to e to the 7 divided by 4. Voila, here's the answer, which actually is c. So now b is e to the 7 divided by 4. This one is e to the 7 divided by 4. So this one, b is e to the 7/4. This one is e to the 7 divided by 4. So the correct answer is c. Okay, guys, I hope this helped a little bit. I'm gonna do one more problem in a second. See you then. Okay, guys, this is the final problem. It's more complicated than the one we've seen before, and the reason is because now you have to start using all those definitions that you have seen in the slides and in the notes about natural logs and logarithmic function. If you remember, we used one rule a moment ago, the one that says b log of b. Log of b, let me see. In a second, let's wait. B log of b of x being equal to x. But this rule only works if this is only one single log expression. That means you have to use another rule, which means the rule that you have to use is this one. Log of b of n plus log of b of n, this is equal to the log of b of n times n. The sum, this is actually the product rule. You know, the sum of the log is equal to the product. This is not, be careful with this guy. Log of n plus log of n is not the same as log of n plus n. This doesn't make any sense, okay? This is wrong. This is true. This is the rule you're going to use. So it would be good, guys, you have at hand that formula sheet when you're solving this problem, just to make sure you're not going to make a mistake with the rules. So the first thing we have to do is we have to turn this logarithmic function to only 1. The way we do that is we apply this rule, the product rule. So log base of 11 of 3x minus 8 plus log base of 11 of x is equal to 1. So we're going to we rewrite the problem. We're going to turn this into 1 log by using this rule, which would be log base of 11 of 3x minus 8 times x is equal to 1. Now that we have one single log expression, we're going to use this rule. And what we're going to do now is we're going to use 11 log of 11 of 3x minus 8 times x equal to 11 power to the 1. Now 11 log of 11, we know this thing is going to drop by using the rule. The rule it was b log of b of x is equal to x. Then we drop here 3x minus 8 times x is equal to 11. We distribute the x, we will get something like 3x squared actually, minus 8x is equal to 11. We send 11 to the other side, and we will have 3x squared minus 8x minus 11 is equal to 0. And what we do now, we have to solve this one. How we solve it? You can use the quadratic formula, where a is equal to 3, b is equal to negative 8, and c is equal to negative 11. And using the quadratic formula that it says x is equal to minus b plus or minus square root of b squared minus 4ac divided all by 2a, then we will have what? Minus negative 8, which is going to be positive 8, plus or minus square root of negative 8 squared, which is 64, minus 4 times 3 times negative 11, which is going to be 132. All of these divided by 2 times 3, which is going to be 6. So we were getting something like this. Positive 8, because the two signs, negative signs cancel, plus or minus square root of 64 plus 132 divided by 6, which is going to be what? 8 plus or minus square root of 196 divided by 6. And the square root of 196, the perfect square, is 14. So this is 8 plus or minus 14 divided by 6. So that means that we have two possible answers. One, it says 8 plus 14 divided by 6, which is 22 divided by 6 is 11/3. And the other one that it says 8 minus 14 divided by 6 is negative 6 divided by 6 is negative 1. Yeah, voila, there we have the two answers. No, not so fast, guys. This negative 1 is not an answer. The reason is negative numbers do not have logarithmics. So this one is not a solution. No, the only solution is 11/3. Why? Because negative numbers do not have logarithmics. And if you go back here to the answer, remember we got 11/3 and negative 1. There's one that it says negative 1 and 11/3, and there's another one that says 11/3. Which one is the correct answer? This one, because negative numbers do not have logarithmics. That's basically the reason why those numbers were invented. Okay, take care, guys. I see you the next time. Solving another problem probably with conic sections. Bye. Take care and stay healthy.